Hi, Eric here. This is my first tutorial. I'll be talking about lists and specifically how to copy over array elements into a list. I'll be talking about recursion. I'll be talking about creating and destroying objects. Not really talking about it, but you'll see it happening in the background. And I'll be using a simple example. I'll be using a math problem, factorial, which is defined 5 factorial equals 5 times 4 times 3 times 2 times 1, which of course equals 120. And try picking up on the hints I use when I use pointers, because I'll use them from time to time. I know pointers are not the easiest thing, but just get what you can. Alright, without any further ado, let's jump in. Alright, so I fired up Visual Studio, and I have it set up with 3 files ready to start coding. What I'll do is I'll start off by defining a constant here. I just want you to keep this in mind, that its use will be apparent later on. And let's include IO stream for basic IO. Good. We'll be using namespace std. So let's go ahead and do that. Okay, let's declare a class here and call it Factorial. Signify the end of the class, and we'll have one private variable, which will be, I'll call it Factorial, which will just store our result. And in public, we'll have 2 methods, actually one. This is implicit. This is a factorial, which is just we're overriding the default constructor and defining our own. And of course, a function to return factorial, which I will simply call factorial function. And we want this function to accept an argument of type int, so we'll go ahead and do that. And save all. Alright. Now let's write the implementation for that. Let's include our header file that we just created. Let's jump right in. Alright, so let's define how our constructor works. Beautiful. Alright, so we'll just want this to initialize a factorial, our variable. And one that's really important, as you'll see later on, I'll be multiplying, and if you multiply anything by 0, our result is 0, so the importance of this will be apparent pretty soon. Alright, so let's think of what we want to do here. This is what we want to achieve. 5 times 4 times 3 times 2 times 1. But how do we do that? Alright. What comes into mind is, or what my mind is screaming right now is, let's go ahead and do this recursively. And how would you do that? Well, think about this statement. Let's go ahead and copy and paste this. Alright, this statement here, I could equivalently do this like so. Copy pasting. Be careful about copy pasting, because if you do make a mistake once, pasting it will only make multiple instances of the same mistake. So be careful. But think about this statement. What does this do? Let's assume this argument is 5. So in the first process will be 5. So factorial gets 5. on the second pass, this is 4. So practice 4, factorial is 5. Since this is an accumulative product, this will be 5 times 4, factorial gets 20, and so on and so forth. And sticking to the contract of my prototype, this is a function of type int, must return a value of type int. So let's go ahead and return this. And we're done. Alright, let's go to our main here. Now, this just has it's a small Java program that just tests how everything works. It of course has a main, which we all know is the starting point of any executable file. So what we'll do here is we'll create an object, or we'll declare a structure here, which is essentially a pointer to this structure, which is an array of factorial objects. Now, this constant here, which I pointed out earlier, this is just a placeholder for 5. It's just saying it's almost the same as saying constant int 5, constant int x equals 5. You can just do that by saying pound define x is 5. So that's what's happening here. Alright, let's now let's actually create the objects. And to create this objects, I will use a for loop. Not assignment, that's what I need. Now let's copy this guy here. Always easy to copy. Alright, so let's create the object here. How do I call that? Yep. Alright, so that's equal to new factorial, which is basically just creating new instances of type factorial here. Now, we know that this structure here contains elements which are actual instances of factorial. So each element here is just a new instance of factorial. Alright, let's copy over these items into a list, and we'll simply do this in one statement. Let's call this the factorial list. Now, you're getting this error here because we've not included the list library, which we'll do right now. There we go. Alright, let's go back here. Alright, so let's fix that. Now, if you look at the template for lists, you can simply do this by initializing this to make this point to the first and last elements within of a structure similar to this, in this case this array. So I'll have this point to the first element in my array, which is that, and the last element, which is this. And now we know the name of an array is basically a placeholder for the first element in the array, so this makes sense. This also does make sense because this is the fifth or the last element. Since this is 0 base, this will be element 4, and by this we've already copied over our array into a list. Now let's go ahead and create an iterator of type this copy paste. Careful though. Alright, iterator, it makes sense. It's just for iterator. We'll have this point to the first element in our list. Alright, now we'll have a loop here to iterate through this list, which has at this time has instances of type factorial, which we copied over from an array. Alright, so that's a precondition. This is an update condition. So traverse this while from the beginning element, which is it, until you get to the end of the list. And let's just increment the iterator to go to the next element. Alright, so just think of an iterator as a pointer, and think of pointers as an implicit int type, which you can atomically increment or decrement to access previous and next values of the pointer. Alright, so what we want to do here is just make a simple cout statement to see what's going on. Okay, we need to define I, and this will just show us our progress. So that factorial is, let's put a tab here just to make everything clean, nice and clean, and we forgot the closing quote there. Alright, we forgot the opening quote. Alright, so what we're going to do here is now just print out a factorial, which can simply be done by, if we successfully dereference this iterator, or this pointer here, this iterator here, this should give us access to the members of type factorial, because in essence these are the instances of type factorial. So there we go. And according to our prototype, we need to give we need to provide a parameter here. So we'll go ahead and give that I. And so let's just put a smiley face here and a new line, and we should be done. Alright, let's run this. Hopefully there are no problems, no errors, but we'll see. Oops. Okay, seems to be an error there. Looks like a quick fix, but I just remembered something. This is really important. We do need to delete all of these elements that we created of type A. So we'll just do this implicitly by doing just having the keyword delete, and then delete should delete all the elements that we dynamically created. That should do it. Okay, and this should go, and that should go. Alright, awesome. We don't need that. Okay, and let's see why we weren't getting any progress here. Once we get that, now we need to call this again. That looks okay. That looks fine. I. Okay, I see that. Okay, the problem here is because we're not incrementing I. I hope this tutorial has been helpful to you. Please log on to www.cs.uML.edu/EGITANGU. You should find complete source code for this project alongside other projects that I've done. Please feel free to comment in the bottom, and let me know if there's anything I forgot. From Eric, see you next time. Bye.